Hi everyone, and welcome to our video on a word problem involving an exponential function. So let's read through this. It says, Wilson invested $50,000 into an account with an interest rate of 1.2% compounded continuously. So whenever they say compounded continuously, I'm going to underline that. It means so they put the numbers already in the equation, but we could have figured out. So just in case they're making us work a little harder, notice the 50,000 is right here. And then this interest rate is the power just changed as a decimal, and then t is attached. So whenever they say compounded continuously, here's a different form for it. We know it's that form where p is the present value or principal, so the investment amount, and then r is the interest rate, but converted to a decimal. Okay, and then t is t, and then I just chose a instead of a of t. Okay, so just in case. All right, anyway, so this means after t years, his account's worth is modeled by already this thing. Number one, estimate the value of Wilson's account after 10 years. Okay, so this is just plug in to our equation. So it's saying use your function that was given, so 50,000 e to the 0.012t, so I'm just rewriting it like that, and we just want to plug in t equals 10. Okay, so 10 years, t equals 10. Okay, so we'll plug that into our t's, so we'll have a of 10 is equal to 50,000 e to the 0.012 times 10. All right, and now we have to be a little careful when we'll need a calculator, but be careful when you plug this in. You can do it in one big step. It might need those parentheses there that I just put. All right, so I have Desmos pulled up already. Let's click on that, and I'm going to type that in. So 50,000 E, and then let's raise it. I'm going to do those parentheses already. So 0.12. And then another thing of parentheses, 10, parentheses, parentheses. Okay, so I typed it in the same way that I wrote it. Okay, so that's what's nice about Desmos. You can make it look the same way. If you have a handheld calculator, I mean, you could use it, it might look a little different, but still use those parentheses, and it should still give you this answer, $56,374 and then 84 cents. Okay, so that's what we have for our final answer. So 56,374 and 84 cents. Let me double check. 56,374, 84. Yeah, okay. And that was our value there. Okay, so the value of Wilson's account after 10 years is, let's just box it, is $56,374.84. Okay, so, and they might ask this as a follow-up. They didn't in this problem, but I'm going to add it. So Wilson earned $6,374.84 in interest. Okay, because his account was 50,000. Now it's 56,374.84. So his account is worth this much more. Okay, so just to get that vocabulary in two to be safe. All right, the next part, it says, what is the rate of change? Okay, so whenever we see rate of change, we're thinking, oh, derivative. Okay, so rate of change is a derivative. So that means let's rewrite our function. So a of t equals 50,000 e to the 0.012t. And then let's get the derivative. Okay, so I'm going to do the derivative in blue because this is ready to go. So we have a prime of t equals, remember the constant's always just hanging out if it's being multiplied by a variable expression, which it is. So that's the variable expression. And then here's our rule for our exponential function. The derivative of it is itself, so we just copy it. There we go. And then times, though, by the derivative of the power. So we look at that and say, hey, do the derivative of that power. The derivative of 0.012t, well, that's linear, so it would be 0.012. Just like that. Okay, and then let's clean it up. So what we should do is multiply this constant with this constant. Okay, so 50,000 times 0.012. I need my calculator again. So 50,000 times 0.012 gives us 600. Okay, so we'll have 600. So we have a prime of t equals 600, and then the e to the 0.012 t still attached. Okay, so that was just the rate of change. So we found it, the derivative. Okay, now let's read the rest of the problem. So it says, what is the rate of change in the value of the count at the end of 10 years? Okay, so now they want us to use the 10 and plug it into our derivative. So we'll do a prime of 10, which is 600 times e to the 0.012 times 10. And like before, if we're doing it in one step, use those parentheses. And back to the calculator. Okay, so I need 600 e, and then to the, let's get that parenthesis, 0.012 times 10. Okay, and we get $676.50. Okay, because that would round there up to 50. Okay, so 676.50. And then because it's a rate of change and so this was the dollar amount, this is per year, like that. Okay, so what this is stating is that the account is increasing, because that's a positive value up there, is increasing at a rate of $676.50 per year at year 10. Okay, so that's what that represents there. Okay, and it should continue to increase every year after that. So just real quick, I'm going to change this to 11. So see, it's a little bit more now. 12, increasing by more. Let's go up 50, so about $1,000. Okay, so as the time progresses, more and more of the amount is going to get higher each time that at the end of each year. Okay, so if this person can live indefinitely, we can start to earn a lot. Okay, so 1,000 years, or if we have a time machine. Okay, so that would be the amount per year that it's increasing. So it just keeps going up and up and up and up. Okay, anyway, that's it though. All right, so if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.